Good evening. We've come to the 5 o'clock hour. My name is Hugh Downs, and we're here for the Shipping Insight 2020 workshops. The last one of the day, the race to 40% greenhouse gas reduction. What we can do today, hosted by Purify Oil. Peter Lindsey, John Carroll, and John Campbell will be giving us the demonstration this afternoon. And remember, 6 o'clock comedy hour. Peter, John, and John, take it away.
Thanks, Huge. Appreciate it. Haven't got used to your name in this conference yet, but it's growing on me and growing on you. Peter Lindsey here with Purify Fuels. I'm here with John Carroll, our CEO, and John Campbell, our chairman. Just want to say thanks to Shipping Insight for a great conference. We've been able to participate so far in the bunker panel yesterday with Dr. Viz. That was a great exchange. A lot of topics that we got into, had a chance to talk about fuel reduction and emissions. Almost made the karaoke last night, but my kid wasn't available to help me with it, so had to skip on that, but that sure was a lot of fun. And then we appreciate being able to do this. And we've got John Carroll in the Shark Tank tomorrow, so there's blood in the water already. Anyhow, I'll just kick us off here. Welcome, everybody. We've got a presentation that we're going to work off of today. If we can see some slides up, I'm not sure if those are up yet. Cross City, there we go. Awesome, there we go. So I'll just make quick introductions. I'm Peter Lindsey. I'm the head of the Marine Group here at Purify. I've got 35 years in the maritime. I used to sail the ships, and I worked shoreside in the terminals and with vessel management, both in the US and Asia. I've worked the last 10 years specifically in the energy end of it, in oil trading, fuel trading, bunkering, and very excited to be here talking today about what I think is an absolute, very solid response to what the times have called for, and in savings of fuel and reducing emissions and greenhouse gases. I would ask John Carroll and John Campbell if you'd introduce yourselves as well, and then we'll get going.
Let's do age. Let's do age before beauty, John.
There we go.
So I'm John Campbell. I'm the chairman of the board. I spent 47 years at Caterpillar before I retired, 24 of that in manufacturing, 23 in engineering. Before I retired, I was the general engineering manager for all of the engine division for 9-liter engines and above, at least all the Caterpillar brands, and also worked the MAK brand as well. In addition to that, I have spent 7 years between 2005 and 2012 on the US EPA's Clean Air Act Advisory Committee, which is a senior level policy committee that advises EPA on the 1990 Clean Air Act amendments. And that committee is chartered by Congress under the Federal Advisory Committee Act. So it's a committee that the EPA did take advice from and work with very closely. So, John?
Yes, sir. So, John Campbell, we joked around at first when he was just a board member that he was our chief skeptic. But then he started to chair our science committee and got more engaged and more involved, and opted to become chairman. He's an incredible asset for us to have. What he brings to the company from a technology standpoint and from a practicality standpoint. And we have some PhD in chemistry on the team, but I don't think anybody can match John's understanding of how an engine works, what's going on in there, and why. I myself am a former marketing executive at Dell. I've always been involved in some newer technologies, and especially in trying to mainstream them. And this is a very interesting technology, and I really believe it is ready to be mainstreamed. In fact, we treated almost 40 million gallons of fuel in the last 2 years, and that number's growing pretty fast. Peter?
Yeah, so let's go ahead and look at the first slide. I think, John, you can kick us off and talk about what we're about as a company.
Am I allowed to hit a button and move ahead, or do I what?
No, it's all being driven by Cross City. They're doing it for us. So let's bring that.
So why don't you go ahead and go to the second slide?
There we go.
Right. So Purify Fuel, and who are we and what is our product, which we call Nano 2? as I just mentioned, we have been used or treated in almost 40 million gallons of fuel, primarily in oil and gas, and somewhat more in a marine. But the technology was actually invented out of Oxford University in the late 90s. Then Solvay, a 14 billion euro chemical company in Europe, took it to the next step and started to design the use of this technology or this chemistry into new designed diesel engines. They have 14 million diesel engines that are out there in design. We formed a 10-year joint venture with Solvay to lead the efforts to actually go after existing fleet owners. So basically, in effect, Solvay goes after brand new engines that are about to be designed. We go after large fleet owners and help them implement this in them. And to that end, we worked with the Houston Advanced Resource Center and the University of Texas to actually refine this product further. And we got a patent out of it, and it's working very well for us. Next slide, please.
We're just going to take you through a brief agenda. The three of us will take different parts of it, but essentially discussing the problem statement, cleaning up the diesel, and how this product works doing that. I'm going to share some data and some results that are pretty surprising. A review of the benefits and terms that our marine customers can actually understand, and then what our rollout is into the ocean and inland markets. Next slide, then.
So the problem statement is pretty simple. It's all about climate change and what we can do to try to delay it and what we can do to try to reduce the impact that fossil fuels have on this change. Next slide, please. There's two primary culprits to a climate change in the fossil fuel part of the equation, one of them being coal and one of them being diesel fuel. We have opted to focus on diesel. And the reason why we have focused on diesel is because diesel's demand does not decrease for the next 20 years. Part of that is because there's no true replacement for diesel. It's the lightest, most efficient form of energy. The other part of that is because the diesel engines last so long. So you're seeing here, we just installed this on a mining work truck last week that was actually built in 1982. It'll be 40 years old in another year and a half. So, these engines last a long time, as you guys can attest to in ships. And I was on a train working on a project, and the train was actually older than I was. And that's really scary because I'm not a young man. Next slide, please. So we'd like to look at this, and we'd like to look at the challenges associated with the diesel fuel in lieu of this environmental, social, and governance model. So from an environmental standpoint, we're looking at, what we can do to reduce greenhouse gases that will clean the air and help to cool the climate. From a social standpoint, we want to look at what we can do for the health and safety of not only the communities that we operate in, but also our employees that are working in and around the equipment. And lastly, from a government standpoint, we're looking at, can we make the business more efficient? Can we help it make more money? Can we come up with ways to make the business more sustainable? This environmental and social and governance model is not about tree hugging. It's a very serious thing. Next slide, please. Because it's driving your access to capital with groups like a Poseidon that are forcing you to file an ESG plan in order to get funding. And it was clearly highlighted by Maersk, who had to come up with a zero emissions by 2050 stance in order to recapitalize the company. And then to add to this, not only is it just the access to capital, it's also going to be your access to customers with the new sea cargo charter and similar initiatives that the charter companies, before they charter your vessel, want to make sure that you have an environmental plan. Next slide, please. So let me introduce you now to our product, Nano 2. So we said before that we worked with the University of Texas and heart to actually refine this product, especially for the use in large diesel engines. So what we have done is we have done the tests that show that based on various engine loads and basic fuel quality. So 55 cetane fuel is supposed to, represent Europe, while 45 cetane is supposed to be more of the norm here in North America. But if you look at this, we're getting anywhere between 5 and 14% fuel savings. But as important as that is, we're also getting reductions in carbon monoxide, unburned hydrocarbon or particulate matter, soot or unburned carbon, and we're getting an improvement or a reduction in NOx due to our lubricity agent. These things add up together. So when you can look at reduced fuel consumption that we're averaging, and we'll show you in real world environments, are about 8%, plus you add onto that a 20% reduction in nitrous oxide, you're looking at a 15% reduction in the global warming potential of your fuel. All this with no engine modification. So we are, it's a simple transitionary step that you can take to get better greenhouse gas results today without having to upgrade and modify your engine. So I'm going to turn this over now to Chairman Campbell to basically explain to you how this works, because it's beyond me.
So, next slide, please. So what I'm going to do is go through the science of how this works. And I know that there's probably some or many of you out there that are always skeptics around what you can do with fuel additives. None were bigger skeptics, as John mentioned, than I was. And so what I'm going to do is show you how this additive is put together, what it actually does in the engine, and what the impact of that is. So on to the next slide. So our patented catalyst is a unique combination of some commonly available product as well as some special product, like John mentioned, from Solvay, as we worked our way through it. One of the elements of the product is 2-EHN Cetane Improver. 2-EHN is probably the most popular cetane improver in the United States. And what we do with that is it allows us to lower the required pressure to start ignition, which means we can initiate the ignition sooner of the burn in the combustion chamber. And because it started a little bit sooner, it does somewhat reduce the exhaust temperatures. In reduction exhaust temperatures or peak cylinder pressure temperatures especially are important to reduce NOx. To that, we add some lubrication improvers and some fuel detergents to help lubricate and clean the engine, maintain injector flow, reduce heat, and restore some lost lubricity. Then finally, the patented catalyst includes the cerium oxide product that comes out of Solvay in France. It's also made on a patented process in France. And what that cerium oxide does, it catalyzes oxidation, and it allows us to manage the pressure. And if we can manage the pressure in the combustion chamber, we can manage the temperature better that's going on in the combustion chamber, because pressure and temperature are closely related or correlate to each other. And so what we do by being able to do that is we extend the duration of the combustion cycle, or the burn, if you will, how long the engine uses the power that comes out of the burn of the product. And that also allows us to burn off soot and carbon deposits. So we're starting injection, we're starting the burn of the engine. We're not starting injection sooner, but we're starting the burn of the fuel sooner. We're lubricating and cleaning, and then we're extending the burn through a longer combustion chamber. So let me show you how that works with the next slide. This is a slide that engineers use to help explain what's going on in the combustion chamber by looking at it by each degree of crank rotation. So what you're looking at here is a map that will reflect the center black line in the map reflects 0 degrees, or top dead center of the piston. To the left is what we call advanced activities. To the right is what comes after the top dead center. So if you, just to orient you the chart a little bit, the left hand, the y-axis is the pressure. 50 bar on that is about 725 psi, just to give you some idea of what kind of temperatures and pressures we're talking about. The x-axis down here is crank angle, as I mentioned, zero crank angle, the top dead center. And this is some data that I'm going to show you that John mentioned at HARC at the University of Texas at Houston, where we did some testing. We did testing on a Cummins ISB 6.7 liter engine, and the engine was well instrumented, so we could tell exactly what was going on in various parts of the engine. And of course, HARC is an independent nonprofit that helped us do this work to get this done. So if you look at this chart, you'll see that on the far left it says fuel injection. That's the timing of when Cummins has established that the injection starts into the cylinder. It's about 30 plus degrees before top dead center. So it's advanced timing, if you will. Because they start the fuel then, the ignition of that fuel actually starts about 4 degrees before top dead center. And then with that ignition, we then have the burn going on in the cylinder, and you see the peak up there that gets up close to 60 bar, then the speed that it comes back down until its exhaust valves close and the exhaust is finished going through the process. So let me take you now to the next slide, which shows what happens once we add Nano 2. Now, when we add Nano 2 to the product, which is what the green line is showing you there, we make no mechanical, electrical, or electronic changes to the engine. As a result of that, because Cummins had set the engine up at about 30 degrees before top dead center to start ignition, that's when the fuel start fueling, that's when the fuel still goes into the cylinder. However, because we've added the enhancer that will help us start the ignition sooner, then we end up with the ability to, with Cetane Improver, to move or advance that timing of ignition from about 4 degrees top dead center to about 8 degrees before top dead center. So as a result of that, we end up with some starting the ignition sooner, starting the burn sooner, starting the stroke as well, that's going to give us the power. But on top of that, when we add the Nano 2 product to it, you can see that we've lowered the temperature peak, or the pressure peak, which is a correlation to the temperature peak in that cylinder. So we're lowering the NOx because oxides of nitrogen are formed by the temperature that's inside that cylinder during the combustion process. The way we do that is the cerium oxide has the unique ability to capture oxygen, or if you will, it captures it on the surface of the particles, so it adsorbs the oxygen as temperature goes up in that cylinder. So we're taking the oxygen away from the burn, but as that temperature starts to go back down on the other side of the stroke, it releases that oxygen, which allows the stroke to extend the burn duration, which gives us then a more complete burn, which gives us lower particulates, and we've kept the oxides of nitrogen down. So we're getting a more complete burn, which if you go to the next slide, is going to give us several things. One, it's going to give us the ability to reduce the NOx formation, as I mentioned. It also gives us more power because we've got longer duration in the burn. We end up with a more complete combustion, which lowers particulates, lowers opacity, if you will, smoke that you see coming out of the engine. And so what we end up with is a more complete process that allows this product to to give you more power, lower fuel consumption, and at the same time reduce both particulate and NOx emissions. The next slide, I'd like to also emphasize that it's safe to implement. There's no caustic or acidic material in this, but when you go and talk to engine manufacturers, the engine manufacturers and say, can I use this? Almost every engine manufacturer will tell you that they don't want you to use fuel additives. Now they know fuel additives are being added. They're being added at the at the refinery. They're being added again when it comes out of the pipe and gets distributed. And they're added again by the individuals that are using the products. So while engine manufacturers know that there are additives going into the product, they'll rarely approve them or never approve them. The best you can get them to do is not object to them. And so what the reason for that is there's no benefit to an engine manufacturer to approve a fuel additive, and fuel additives are something that they have to have. They wanted to measure all of them. It'd take a significant amount of effort and resource if they wanted to try to do that. Well, rather than say they're going to approve a fuel additive, what they do is ask us to be compliant with the product that we add to the fuel specs. On the right-hand side of that top, you see that we are compliant to the ASTM D975 spec, as well as the European EN 590 specs. We're also compliant to the biocide specs for both the ASTM and biofuels that are being used. But what the engine manufacturers ask us to do besides that is meet some individual requirements that they have. And so we have gone out and asked Bureau Veritas to independently test the fuels with our product in it. And they've confirmed with us that the engine does meet the published specifications, Caterpillar, Cummins, MAN, MTU, and other engine manufacturers. It also works on marine gas oil, Caterpillar, EMD, and Wärtsilä engines. We actually got a letter of no objection from MAN that can use our product in both 2-cycle and 4-cycle engines. So in essence, what we're saying here is as long as we meet the manufacturer's spec, it shouldn't have any impact at all on any of your warranty. This product, as John said, has been tested heavily and used around the world. The French Institute of Petroleum has confirmed that it will not harm engines or fuel systems. It enhances soot oxidation and cleans engines. And one thing to keep in mind is that cerium oxide in this form doesn't melt until greater than 24 degrees Celsius, and typical combustion engine temperatures never make it that high. Being used in 14 million engines worldwide with no issues. We haven't paid any warranty claims, but we do have a warranty in case something would happen, but we've not seen anything, nor has anybody else seen any kind of a warranty issue caused by nanoceria. But we do have a warranty available on top of that. And it's used in it has been used in major European population centers such as London. So it's a product that's safe to use, it works, it's safe to implement, and I just went through how it works. So let's go on to the next slide. I think I'll turn it back to John.
Yeah, I'll kick us off here. John Carroll, you're on mute. So let's talk about testing. And thank you, John Campbell, for that. We're going to prove now how the catalyst reaction works and the outcomes that we've experienced. Next slide, please. So we've got two independent tests listed here. One involving a smaller 4-stroke 6.7 liter Cummins engine. That test John referred to as the HARC study at Austin, Texas, University of Austin. Sorry, UT Austin. I better get that right in case anybody in the crowds went there. And then the larger 2-stroke EMD 3000 horsepower engine that was tested down in Louisiana. That test was run by NRE Power Systems on their dynamometer. So we'll come back to these results, but the important distinctions are that there's similarity in these fuel efficiency gains under different engine loads that you see up top there. That's the upper table. And the emissions gains, which are spelled out in the lower table. You see the similarities, even though these engines are pretty far apart on the spectrum, 4-stroke versus 2, 6.7 liter, probably 500 horsepower against a 3000. So again, we'll come back to these, but let's first talk about how we test for proof of our performance. Next slide, please. So between the engine and the work we get out of it, there's different power losses that could be experienced. Some call them parasitic loads. In the case of marine, you've got wind, current, tide, bottom condition, propeller condition. You've got all kinds of things that would experience that would have an impact on your performance that could get penalized against your fuel or wrongfully benefit your fuel burn where that's not actually happening. So our approach is to measure the power at the engine against the exact fuel used to generate that power, regardless of how it's used. In the marine case, we install a strain gauge to measure kilowatts or horsepower in frequent intervals with the data being captured. And then we match that up with our fuel flow sensors, netting out supply and return lines, as you know, diesels have. And then on top of that, we measure either spot or continuously the emissions in terms of oxides of nitrogen, carbon monoxide, particulate matter, opacity, et cetera. So here's a quick look at how we evolved in testing our locomotive customers. Unless, John, you want to jump in on anything there? You're on mute.
No, I thought that was I will jump in if needed, but you're doing great.
Okay, good. Thank you. Let's go ahead to the next slide. We'll take a look at the locomotives that we started with. So we started on like a half-a-year test in a closed loop system on a switching train, doing the same work, the same hours, and the same loads every day. We got a very accurate and repeatable gallons per day consumption rate. You see that on the lower left, that we compared before and after during the use of Nano 2. So then we implemented flow meters. This is the middle test, the one at Little Rock and Western. On a different train with a larger engine, you see we stepped up from 1,200 horsepower to about 18 to 22 and came up with a comparative flow in gallons per hour over a full year's time. That was a long test, but we got a lot of very, very consistent readings and data. And then finally, we were able to pick up in a later test about, that was about, what was that? About 6 months as well. On a larger engine, about a 3,000 horsepower engine up here in Puget Sound near where I am, and saw very similar results. You see the savings, the fuel savings across the bottom, pretty consistent. So let's take a look at a marine engine test. This will be a 3,000 horsepower tugboat engine that was tested. That's the one that we did at NRE down at Louisiana, Houma, Louisiana. This is a video produced from the testing process and some commentary from the lead mechanical officer at NRE that ran the test. So hopefully, Cross City, you can get us next slide, and that should be the video. We'll watch it. There we go.
Peter Day, I'm senior technician and I work for NRE Power Systems. NRE is a full service provider with parts and service for marine, rail, and power generation. I have 43 years of mechanical experience. I've worked in emissions, research and development, running repairs, field service. I've done extensive testing in additives, emissions, and our emission certificates with the EPA. Today we're running a test on Purify Fuel Nano 2 additive catalyst product. I've tested a lot of products in the past. I was very skeptical. Most products is what we would call snake oil and never meet the expectations. The engine being tested today was pulled out of a vessel a few months back, was built in 1975. The data we are collecting is horsepower, fuel consumption, emissions being NOx, CO, SO2, and any other EPA-related pollutants. We ran the engine for about 150 hours. We ran it at various RPMs at various loads, just like it would be in the locomotive. The primary challenge with reducing emissions and reducing fuel usage is if the carbon monoxide increases, the NOx decrease, and vice versa. It is a very difficult process to get both to meet emissions. With Nano 2, we have seen a decrease in both, which is very impressive. I have never tested anything that lowered both at the same time. Fuel consumption was decreased, pollutants were decreased, opacity was decreased, which is the smoke coming out the engine, which is directly correlated to particulate matter. When we added the additive, the engine had a more crisp, powerful sound. The overall performance of the engine increased dramatically. In my 43 years, I've tested a lot of products. I have never seen a product, or even heard of a product, that would perform this way. None of them compared to Nano 2. Everyone is looking for a better planet, and Nano 2 Purify Fuel reduces emissions, reduces fuel consumption, increases engine performance, and is very impressive.
Okay, next slide, if you would. So the results that NRE was referring to, there was a brief snapshot in the video that you couldn't really see, so we're showing it to you here. These are in terms of fuel gain, fuel consumption, if you will, reduction, emissions reduction, and the other noted outcomes. I'll just repeat one thing that Mr. Leday said in the video that he was most surprised about was the actual reduction of carbon monoxide at the same time as a reduction in NOx. Typically, those are interchangeable. You get one, the other one goes up, you get the other one, and the first one goes up instead. This was a simultaneous reduction in both carbon monoxide, which is an indirect greenhouse gas, and oxides of nitrogen, which are very direct greenhouse gases. In fact, one of them is a really bad actor. So anyway, that was these are the results that came out of it. The engine fuel efficiency gain was depending upon the load factor. The soot, it was a notable, in fact, John Carroll, who's on this presentation, was actually there during the test over 12 days. And it was notable, the soot reduction, and even the noise reduction, even a lower noise.
Go
ahead.
No, and I thought the other thing that was pretty incredible is we had an engine that was doing almost exactly 3,000 horsepower at notch 8. And after adding the product and letting it double dose for a couple of days, it was doing 3,250 horsepower, right? And so that increase in power just goes to show what John Campbell was saying is a greater percentage of the fuel is being burnt during the actual power stroke, which is driving that gain in power. And to top that off with the lower heat is pretty impressive.
Right. So in keeping continuity on that, we're rolling out our next live product trial on a bigger vessel. With a bigger, these are EMD twin 710s out here on the West Coast shortly, and we'll have some updates for folks as we keep in touch. Let's go to the next slide. John Carroll is going to talk us through some of the benefits a little bit. Here we go. Next slide. Next slide. There we go.
So from an ROE standpoint, and I'm going to try to make this slide a little bit bigger because I can't really see it very well. No, that doesn't do it, John. All right.
Just click on the window, the slide window.
Oh, really?
There you go. Yeah. Does that work?
No. Anyway, I think I recall this one. So based on the different ISO testing methodologies, we got either 7.3% savings in what they call line haul operations, which is or we got upwards of I believe 8.9% improvement in switching up operations. If you look through those, and this is actually a customer who burns 57 million gallons of diesel a year, it'll show you that, at roughly 8%, you're saving about 12 cents 12.2, if I recall correctly, per treated gallon at a cost of roughly 7.2, or you're saving basically 5 cents per treated gallon. That means that for every dollar that you spend on our product, you save $1.69. So it has an instant payback. Next slide, please. So on this benefit, on the average of 8.1% fuel savings, we sell our product in either 55-gallon drums or 275-gallon totes. On the drum side, we basically cost around $3,000 per drum, but we treat 41,250 gallons of fuel at a fuel cost right now of $1.50 a gallon, or for every $3,000 you pay for our product, you save $5,000 in fuel. Same thing on the drum again. For every $15,000 that you spend on a tote, you're going to save $25,000, right? So there's savings truly out the gate. That's why we call it return on expenditure and not return on investment, because there's no upfront, engine modification or upfront costs that you have to pay. You simply splash fund it with your fuel, and it works. Next slide, please. This increased power thing, I think, is explained best in fracking. And fracking was our first customer and our biggest customer. When we first went in there, in the bottom middle area there, you're going to see a test that was done in a lab, and it looks at the same power levels with our product and without it, and it looks at the improvements. And overall, based upon the weighting of it, we expected to save them about 6.2% in fuel. This did not surprise us being a little bit lower, because these fracking pumps operate at such a high load, right? They're at 85% load. But if you look at the bottom left-hand chart, what happened was their internal audit group went back there and they did an audit of the actual fuel bills and did an audit of the ECU to see what was going on inside the engine during that time frame. So after 250,000 hours of operation, they discovered that the additional power that was being generated by the engines allowed the pumps to actually work at a more efficient gear setting. That actually increased their savings to somewhere between 8.2 and 8.7. And we even have additional data since this study that is just being done now, where they claim that they're actually receiving, if you look at it in terms of 100,000 hydraulic horsepower hours produced, that they're actually saving 9.3%. So that happens to be, I think, a major reason why the CEO of what is now called NextTier, which was back then called Keen, basically came out and stated that in their annual report that the usage of nanotube fuel additive in our diesel supply has resulted in reduced fuel consumption and as much as a 50% reduction in air emissions. And what he was talking about in terms of air emissions is we first started to work with them in Denver, and people were literally fracking in their backyards. And the black smoke was all over the place. And we have some time after this, I'll actually show you a picture of that. But we actually, you could still see some smoke, but they claim it was almost an 80% reduction in opacity. Next slide. This is a good example too. The picture on the left, middle left, or actually kind of center left, is the spark arrestor on top of the smokestack. And this was the second test we did that Peter referred to. And that was taken by me when we were doing all the baseline testing and getting the emissions data before we dosed the engine. We actually brought a senior technician from Amtrak with us, who is a close friend and does a lot of help for us. And he was there, and started up the engine, ran it. Then we dosed the engine. We flew back in a little over 4 weeks later, and that's an untouched picture of that same spark arrestor. So what happened between left and right is the oxidation catalyst turned the carbon deposits into carbon dioxide. So it basically, without doing anything to damage anything else, it just removes the carbon deposits. If you look at the benefits up there, you see that they love the improved carbon deposits, and that the bottom right 4 comments there is, after 3 years, every 92 days they tore down these trains and looked at it, and they found that they had increased compression. They found that the oil life appeared to last longer, that the engine was quieter, and it had increased horsepower. Next slide.
Right. So I just want to make a comment. You know, I've enjoyed this conference so far. I was able to catch a few sessions live, and then I had to go back and look at a couple of sessions on the video replay, which I'm glad that we have. But one thing that kept coming back, I mean, there's this theme on ESG and sustainability. So I thought it was important that, you know, we take this discussion about Nano2 and the technology and the results and put some of this in terms that are addressable to the challenges that our companies have today. Ship owners, ship operators, charters, the whole community that's here at this conference. And that comes down to ESG and sustainability. So let's jump into the next slide. I'll show you where we're going with that. So we know that Nano2 supports any and all sustainability requirements of the marine market in basically three ways. The direct environmental benefit with the reduced emissions that John talked about, the community benefit and cleaner exhaust, which are directly linked to human health. There's all kinds of chapter and verse written about, especially in the oxides of nitrogen and the particulate matter, depending upon the size of the molecules, the size of the particulate, a direct impact on human health, human lung. The maritime industry has already taken a big jump this year, as you know, with the reduction of sulfur, which then creates sulfur dioxide, which is another human health hazard. But we're still open here, and we've got to address the NOx and the particulate. And then the third one, really a corporate benefit in cost reduction through energy savings alone. Without the degradation of workplace and job loss and offshoring and all these other things that we read about, this is an example of where you get energy savings that supports good corporate governance without the downsides. It's a very powerful sustainability support for what corporations are being asked to do today, right here, and we support all three. Next slide. So taking those same benefits into real numbers, we use our experience.
So remember when I talked about the fracking site, Peter?
Yeah, just now you mentioned it. Yeah,
this is the picture that that we took, and this is the city of Boulder was about to ban fracking. So what was then called Keene brought us in. They had us do a kind of a special heavy duty industrial configuration, and they wanted to see how much of that smoke that they could stop. Right. And the top picture there was taken exactly 1 day prior to us adding the product to it. And the bottom picture is less than 24 hours old. So you can see that's opacity, but that's all particulate matter. And that was actually being fracked near schools and people's backyards, et cetera, et cetera. And so that's one of the primary reasons why they did it, is to get rid of all that smoke. And of course, to save money. Sorry, Peter.
Same engines running, John, on the upper picture and the lower picture, same power plant, same levels, right?
Same exact frac pad. It was right mid-frac that we installed it.
Okay, great. So taking those benefits into real numbers, we use our experience in drilling and fracking, as John just talked about, to illustrate the impact on carbon reduction. Over the course of any amount of diesel being burned, there's a specific outcome tied to it in terms of tons of CO2 reduction in the atmosphere. And on top of that, the other more harmful emissions are coming commensurately down with it. So you see those other we could go back and talk about those other emissions down there in the blue squares. But there's definitely a tie between these. Next slide. You went one extra, I think. We missed one. There we go. Perfect. So expressed in terms of global warming potential, which is another topic or another theme that companies are being asked to speak about these issues in. We look at carbon reduction in terms of both CO2 and CO2 equivalent, or CO2e, which accounts for the greenhouse gases with up to 300 times the impact as CO2 on global warming potential. So we can even calculate the equivalent in terms of cars being taken off the road with these specific savings as it relates to the use of Nano2. We gave you the example of a 55-gallon drum. That's about 15 cars off the road, and then all the way up to a 275-gallon tote, about 75. So just an interesting perspective in how we can pose that in terms of global warming potential and what we're taking out of that equation. Next slide, please. So all companies today are being asked to look at their carbon impact in different ways, or scopes as they're termed. We all have a scope 1 on concerns on what we do for a business, and we're all a scope 2 or 3 for someone else, depending upon how we're being utilized by our customers. So by reducing carbon emissions in marine engines, we're not only helping our customers, but we're helping their customers as well in this total framework of carbon intensity. So when you hear about scope 1, 2, and 3, that's becoming a pretty common discussion right now. This has impact on the entire chain, especially as we go into power generation with Nano 2, which we are, by the way.
What's interesting about this too is I've been asked by a number of our customers to go out and visit with their customers. So scope 3, if you are a shipping company or a rail company, you are a scope 3 provider for your retailers. So I've gone to Kimberly Clark.
Actually, next slide. That's our next slide here. Go ahead.
I know. I just want to make sure they see the scope 3 stuff there.
There you go. Sorry. Okay.
So we've actually had the ability to go out there and talk with customers and show them this stuff and help them document it in such a way as to help them get a larger share of the business from their customers who have these initiatives like Georgia Pacific. And it's very fun to go out there and to use, this whole greenhouse gas things to help your customers get more business.
Go ahead, next slide. John, why don't you grab this and then I'll take the one after to finish up marine.
Yeah, so I know we were all aware of what happened in the second quarter of this year when, for a while here, near Houston, the price of West Texas actually went to minus $37 a barrel. We went from, roughly $2 to $2.10 for off-road diesel down to 67 cents. Fortunately for us, we have pegged the price of our raw materials to the price of, crude oil. And so we were able, even at 70 cents, to reduce their price to ensure that they always got a return on expenditure. So, we always want to work with our customers. We always want them to do all 3 parts of ESG. We want their environmental to be better. We want their employees and their communities to be safer. And we always want our partners to make more money. Next slide.
Great. And I'll finish it up. We've been asked a couple of times in this conference and even prior to that as exactly what is the plan in marine. You've heard about our exposure to rail. We've got over 300,000 engine hours in rail in a lot of different companies all over the country now. And those rail engines are it's very similar, if not in some cases identical, in tugboat engines. But we've also got the fracking and drilling, the oil and gas exploration side of it, where we've got over a million engine hours now. And I think, John, you said 40 million gallons, I think, treated in that case. So coming into marine, our rollout plan kind of looks like this, where we've divided it off sort of by the engine type and size and the fuel being used. So in the inland waterways and the offshore industries, very, very intensive for marine gas oil, tugs, ferries, OSV, oil rigs, that kind of thing. And then there's this middle section in the coastwise and passenger, where you've got product and Jones Act tankers, at least out here on the West Coast where I'm at. You've also got some activity from Houston around to the East Coast. And then the cruise lines are pretty much going now all on marine gas oil as well. Or they've taken some other abatement procedures like scrubbers and that sort of thing. So those are immediate use of Nano 2 into gas oil. And then in the deep sea vessels, we got a proposed test coming up on a coastwise tanker that's actually an IFO type engine, but it will be using first, of course, marine gas oil. And then we'll be able to find another platform, similar size engine, MAN engine, what John Campbell had mentioned earlier, who's given us the letter of no objection to use this. And that then gets us into VLSFO shortly after that, for the grades of VLSFO that are being offered today around the 100 viscosity area. And that would take us into container and bulker, and of course the big tankers. That's kind of what it looks like. And that will be our process forward. Marine gas oil and then VLSFO. I think that's pretty much it. Let's take the next slide, and we'll address any questions or go back and revisit any other points if we have any. Okay, we're going to go ahead. I don't think we've got any. They said, yeah, go ahead and conclude it as we want. We'd like to thank you so much from John Carroll and John Campbell and myself for welcoming us into Shipping Insight. We've had a lot of good feedback during the conference, a chance to meet some new folks and get some new ideas, but we are charging forward with this. We're very confident in our data. We're confident in the chemical, the chemistry behind this additive, and we're very grateful to be part of a solution to a problem that is so prevalent and so widely discussed at even this conference. So on behalf of John and myself, John, go ahead.
Yeah, I'd be remiss if I didn't thank too. We have, great distributors. We signed, Mencast in Singapore. We signed the Canoe Group in the Middle East. We're working on, a direct office, in Europe, and we're of course here now. But we have some great partners. We have some very, aggressive plans, and so far it's been very enjoyable to work with so many of you. Thank you.
Well said. Thanks, everybody. We'll see you at the comedy night at 6 p.m. starting soon. Thank you, Cross City and Shipping Insight.
Really impressed with the production. Thank you very much, Peter, John, and John. Fantastic discussion. But as Peter mentioned, in a few minutes, we're going to go to comedy. 9 minutes from now, I'll come back then. My name is Huge Downs. Take care.